Hello everyone. What if you could run two completely different operating systems on your Raspberry Pi 4 and switch between them with just a single simple command? Uh, no need for dual SD cards, no reflashing, and just instant switching. So in this series, I'm going to create two videos. So in the first one, I am going to let's just talk about the whole picture for a second. So I'm going to show you how to build a professional dual boot system using U-boot as the bootloader. And by the end, you will have two independent operating systems working on the same SD card and a simple command you can use to switch between them and the ability to update the inactive operating system via the running operating system. So in this first video, we are going to create partitions on the SD card. So we are going to have the four partitions there. The first one would be the bootloader. The second one would be operating system one, then operating system two, and then we will have a data partition for any shared data that we need. So let's just, so I have an SD card. I have these four partitions already present there. So what I'm going to do first is I am going to make a uh, variable with this my SD card name. So for example, I have this SDB uh, dev SDB. So I will create this SD card variable. So because we are going to use this in this series, so I've created this. So after this, I will unmount all the partitions that are listed here. Let me just, okay, we have unmounted all the partitions. So now we are going to use parted command and erase this whole SD card. So we are going to create new partitions here. It will ask you yes to erase all your SD card contents. So after this, we will have an empty SD card. So now let's create the partitions. So here is our first partitions. We are going to create first one. I've saved all these commands in a document. So I will just copy the rest of the commands here for the next three partitions. Okay. So after this, we need to set that boot partition. We set the boot flag on that partition. Okay. So now we erase all of these partitions one by one. All right, that's the last one. So now we have the four partitions. So next thing we're going to do is, so we are going to mount the first partition. That's our boot partition, and we are going to compile the U-boot for Raspberry Pi 4. That's our current hardware. So we will compile that and place the U-boot binary in the boot partition. But so the Raspberry Pi expects a certain specific name for the kernel that they're going to use. And they are different for each Raspberry Pi. So for Raspberry Pi 4, we have kernel 8.img. So that's the file the firmware looks for in the boot partition. So Raspberry Pi first boots into the internal firmware, and after that, it jumps into the boot partition and it looks for this file. So we are going to place that file there. I already have the U-boot binary here, but we are going to recompile it. So we will first make it for Raspberry Pi 4. So it will do the necessary make steps, and then we are going to compile it. Just a couple of things we need to make sure here. In the environment section, we need to make sure that environment is a fact file system. So after that, we need to make sure we have the environment variable set here, environment. We have the partition number set here and the environment file name set here, environment size. So these are a couple of checkpoints that we need to make sure we have in the order here. So after that, we can just compile this and copy the binary into the U-boot partition, but we didn't rename it to kernel8.img file. Find the move finally. So we have it here. Now we are going to copy that. So these are the firmware files that are provided by Raspberry Pi. So we need to our boot partition needs these files. So for Raspberry Pi 4, we need start4.elf and fixup4.dat file. So we need to copy this file into the boot partition, both of these, and we need to make sure we have the device tree file here. For Raspberry Pi 4, we have the BCM2711. So we copy that into the boot partition. The next thing we do is we put the boot binary in that folder and we rename it to the kernel8.img file. Right. So these are the files that we have in the boot partition right now. So uh, we are going to make sure first that we have the U-boot running properly on the Raspberry Pi 4. After that, we are going to copy. I have downloaded Raspberry Pi OS. So we are going to copy that into the partitions 2 and 3, both the OS partitions. So we are going to do that in the next video. First, in this video, we are going to enable the logs here and we set the kernel image here. Just a small comment in this file. We provide the device tree name here. These are pretty much the standard variables that we need to set into the config.txt file. So after we have done that, I think we're done for this. So now we are going to unplug our SD card and place it in the RPI4 and let's power on and look what happens. Alright, we have the logs here and you see we have the U-boot running here. So I am using U-boot version 24.1. So you can change that, but it's a stable release, so it's good to use that. So we have the U-boot running. Now let's install the other OS partition. And we are going to do one more thing before ending this video. So like I said, I have the Raspberry Pi OS already downloaded in my PC. So we are going to uh, mount that onto a loop device so we can copy those context onto our partition 2 and 3. So let's just find out where it's placed. I believe it should be in the downloads. There it is 2025 12 for Raspberry OS. Okay, so we are going to use the loop setup to command for that. Alright, so you can see we have the loop 24 device and that's our OS. These are the files that we're going to copy onto our partition 2 and 3. So we are going to do that in the next video. So we can also print that. So we're going to mount it onto the image root for directory here, loop device, okay, partition 2, image root. Okay, so we are set up. So we can just copy these files onto the OS 1 and 2 and do our changes with that. See you in the next video.